Welcome to this video on multiple configurations of capacitors. In this video, what we're going to take a look at is what if you connect more than one capacitor to a battery? Would it add energy to the circuit? Would it remove energy from the circuit? Would they have to share something? Or would each of them act as if the other one wasn't there? And so that's what we're going to talk about in this first overview video. Now the first thing we have to do is discuss some nuts and bolts, if you will, okay, some symbols. We talk about circuit schematics often, which are diagrams that help us build circuits. So it's kind of like the instruction manual for building a particular circuit. And we use different symbols to represent different circuit elements. Now circuit elements are the devices that you would attach in the circuit. One of the ones that we've discussed a little bit in this series so far is the battery. We have one long line, one short line, represents a cell, and you have to have at least two cells to make a battery. Then we draw the wires coming off the sides. The long lines represent the positive terminal of the battery. The short lines represent the negative terminal of the battery. Second to that, we have the capacitor. Soon we'll add many more. One of the symbols for the capacitor are two equally long, so the same length, parallel lines. So it looks very similar to the battery, except the lines are the same length. Now there are other symbols for the capacitor and the capacitor in different states, but we're going to keep it simple right now and just use this symbol to show. A wire is obviously just going to be a connecting line, and remember this is a conductor, so these will allow the flow of the electrons. What we also want to describe here is a new term that we've used kind of loosely so far, but this is the term current. Now current describes the amount of charge, so Q, amount of charge, passing a point in the wire or a point in the circuit in a given amount of time, T. And we use the symbol I to represent current, and you can use uppercase or lowercase I to symbolize the current. Now remember, in order to have moving charge, in order to have a current, I have to have a potential difference of some kind. There has to be something that keeps a potential difference across the conducting path. If there's no potential difference, which we also know as voltage between the 2 points, then there'd be no current between those 2 points. And that's the job, the role or the job of the battery. It is to provide the potential difference across the entire circuit. So when I think about different ways to connect capacitors to a battery, one of the ways that comes to mind is probably just the most simple way, which is I take a capacitor, I connect it to a second capacitor, and then I connect both of those to a battery like this. Okay, this configuration is known as a series configuration of capacitors, and we'll talk about where that term comes from. But some people might instinctively connect, and here I'll do the actual battery there. Sorry, I did a shortcut version. What we might do is we take these two wires connected to the battery, and then we introduce a splitter. Okay, and the splitter can take the wire up this way to connect one of the capacitors, but the splitter could also take the wire this way to connect to the second capacitor. And this configuration is known as a parallel configuration. We see that these circuit elements are parallel to one another. But there's actually a better way to distinguish between series and parallel circuits, and it has to do with the splitter over here. Now we don't actually use the term splitter very often, although that's basically what it is. We rather use the term node or the term junction. If you think of a junction in a road, it's the point at which you have to choose to go right or to go left. The splitter is the idea that if you wanted to share headphones with somebody, right, and you didn't want to each only have one of the headphones, you could attach a splitter first and then attach a pair of headphones to each of the ends of the splitter, which connect to the music device. So when I look at this kind of circuit, a parallel circuit, what I say is if I trace the path from one of the circuit elements to the next circuit element, which here could be the battery or could be the other capacitor, there is a node in the path between the circuit elements. So a parallel circuit is one in which a node exists between two circuit elements, or we would rather say that these two circuit elements are connected in parallel with one another. So it's all about the presence of the node. Now we would say that two circuit elements are connected in series with one another if, when I trace the path from one circuit element to the next, there is no node between the circuit elements. So oftentimes in introductory electromagnetism courses, teachers refer and books refer to this as a series circuit or a parallel circuit. And that's a little bit oversimplified because oftentimes, and in reality, you're not going to have just a series or just a parallel. You can have some combination of both. So it's better to say this element is connected in series with this other, which is connected in series with the battery, right? Or this circuit element is connected in parallel with this, but could also be connected in series with something else. Now we're going to label our capacitors C1 and C2, and here I'll label these also as C1 and C2, and we're going to take a look at what should happen. Now, the main thing to remember is that if there is a potential difference between 2 points, then there will be a current between those 2 points. If there's no potential difference between the 2 points, if something eliminates that potential difference, then there will be no current between those 2 points. And that's going to be where we pick up in the next video, is just taking a look at just the series configuration. Then in the subsequent video, we'll take a look at just the parallel